Got about a minute left on the quiz. Make sure that it gets in. Make sure you have the notes. Make sure you have the practice. Okay. Again, make sure those quizzes are turned in. On the notes, we are looking at something called Pascal's triangle, and they want you to do A and B there. Peter will stop moving on me. If you look over to the left on the wall, you'll see Blaise Pascal over there. Somewhere. Yeah, he's up there on the top right poster. And one of the things he noticed was this triangle. You start with the ones on the outside of the triangle. So you see the black ones that are there. And then what you do is after the second row, you take the numbers and you add them in the space in between. So 1 plus 1 is 2. So now in this row, we have 1, 2, 1. To get the next row, add 1 and 2. That space becomes 3. Add 2 and 1. That space becomes a 3. The outsides are always 1. And they keep doing that. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. So could you guys help me with the next row? What would the next row be? Have to start with a 1. And then what? 1 plus 5 makes 6. 6 plus, or 5 plus 10 makes 10 plus 10 makes 10 plus 5 makes 5 plus 1 makes, and we end with a 1. Let's keep going. It starts with a 1, and then 1 plus 6 is 7. 6 plus 15, 21. 15 plus 20, 20 plus 15 again. 6 plus 15, 6 plus 1, and it ends with a 1. And we can do this one more time. Let's see, there's going to be a 1 there, 8 there, 28, 56, right? 35 doubled is 70. 35 and 21 is a 56. 21 and 7 is 28. 8 and a 1 on the end. This can go on forever, Pascal's triangle. Now, part B says, hey, find the sum of each row. So if 1 is there, it adds up to 1. 1 plus 1 is 2. 1 plus 2 plus 1, 4. 1 plus 3 plus 3 plus 1, 8. 1 plus 4 is 5. Plus 6 is 11. Plus 4 is 15. Plus 1 is 16. Anybody notice the pattern? They're doubling the what? The previous row? So what's the answer for this one going to be? You take 16 and double it. You take 32 and double it. You take 64 and double it. 28. And the last row we did should be 256. And that would keep going forever, right? There's a lot of interesting properties about Pascal's triangle. Here's another one. Look at all these numbers. 1, 2, 3, 4, 5, 6, 7, 8. Isn't that just counting? So yeah, there's a lot of neat little factoids within his triangle. It's very powerful. It's very useful. We use it in a lot of real world applications. Computer science uses it all the time. Password security uses it all the time. We use it in data. It's found in nature. I mean, it's all over the place, the thing that he discovered. In math, there's a big argument. Is something discovered? It's already out there for you to find, or do you invent it? If it came from your mind, did you invent it? So a lot of people debate. This is one of those debates. Did he discover it because all these facts are within it? Or did he invent it? Can you invent facts? Who knows? But yeah, so Blaze, notice that. But if you can remember that triangle, it's going to be mighty useful. Now, one of the things that we're going to talk about is called an identity. An identity is a pattern of recognition. And one of the biggest tools we've talked about is factoring, right? We've said you've got to know how to factor. It's one of the biggest things we do all year. It's very important. We factor trinomials with the big X, right? So that's not going away. We're going to do it again. And we're going to do what we did last class, which was multiply. But I'm going to teach you how to do it faster. Okay, so nothing wrong with using the big X like you just did on the quiz. Nothing wrong with that. But if there's ways to do it faster, why not do it faster? So now there's two things that are going to happen today. If we go from something already worked out to the factors with a But if we go from factors, and what's the operation here if the parentheses are hugging? That is multiplication. This is a product. Right? If we multiply factors, we get a product. If we undo the product, we factor. So our goal today is to be able to go from one to the other. That's going to be our goal today. So what we're looking at here is called a difference of squares. It's saying something's being squared. And then when you hear the word difference, that means subtraction. So the difference of another thing being squared. So we have to keep square roots in mind. Y'all, what's the square root of 25? 5. And then what do you square to get x squared? X. So look, they're saying, hey, the first part is really 5x squared. Right? If you square all of that, you get 25x squared. Now, what about here? What's the square root of 36? 6. And what do you square to get y squared? Well, that's how we got this part, 6y. So we say this. Minus 6y squared. Now, when we're factoring it, it's actually super easy. Here's how they got this answer. You take the two values that we got, 5x, 6y, 5x, 6y. We just write it twice. Okay? We write it twice. All we do is one side's positive, and on the other one side's negative. Remember how we factored with the big X? If we were to do that, we'd get the same thing. But it would take even longer. Questions? So that's called a difference of squares. We're going to see it a lot. In fact, let's come back here. And isn't this a difference of squares? Right? If you look at it, this is A minus B, A plus B. I need you guys to multiply that in the box for me real quick. Multiply that in the box for me. See what you get. I'll be right back. Yeah, multiply that in the box. Let's see what we get.
That sounds like how I'll be coughing all week. I like one bar. What? One bar. Those are those. I was like, that's the way it's okay. Do you know what that is?
Okay, let's see what we got. You guys just did that for 90 seconds, right? You got an answer?
Yeah.
Okay, watch. Ready? I'm going to do this without a box. Elise, ready? I'm going to do this without a box. It's going to take me less than 10 seconds. Did you get 64x squared minus 9? Yeah? Yeah? How'd I do it without a box? Now watch, watch. So this is why we want to know these shortcuts. Look, the difference of squares is a squared minus b squared. If I can remember that, I don't need a box. If I can remember that, I don't need the box. If I can remember that, I don't need the box. Will the box get you the right answer? But didn't it take you 90 seconds versus I did it in 10? Trying to save time. ACT comes up in February. Why wouldn't you want to save time? Yeah? Now let's go to here, C. Right now, you might be thinking, oh, that's intimidating. That's okay. It's day one. But in a month from now, you should be like, oh, yeah, I got this. So that's the difference of squares. First off, does everything have square roots? Look at the numbers. Every one of those have a square root?
Yeah.
And a subtraction? By the way, when there's only two terms, that's usually a difference of squares. Usually, not all the time. So can we work this backwards? They're giving us the answer that was in the box. But we can work this backwards. So we're going to say, okay, one of them is going to be plus. One of them is going to be minus. All we got to do is take square roots. What's the square root of 36? 6. And what do you square to get x squared? X. X. Somebody help me out. What's the square root of 121? You sure? Nah, it's just 11. 11 and negative 11. Okay, and then what do you square to get y squared? Y and y. That's it. Because how do we know that? This is a squared minus b squared. And that turns into a minus b times a plus b. I'm just going backwards, right? That's it. That's it. How could you double check your answer? How do you know if you're right? Let's say you doubt yourself. Doubt starts creeping in. What could you do to know that you're correct? What are our two factors doing? Operation one. Right here, these two. What are these doing? They're multiplying. So guess what? If you multiplied it out, shouldn't you get this? That's how you can check, right? Put this in the box, see if you get that. If you did, then you know you did it perfect. And say you do it over and over and over again to get confident. Yeah, if you got the time, multiply that out. If you get what you start with, you know you did it right. Okay. That's difference of squares. Do we have any more difference of squares? Any more? Nope, just that. Okay, let's go to the next one. Go back to our chart. That was all difference of squares. You go forwards and backwards with it. Number 2 says what? Square of the sum, some squares. Okay? So what does it mean to square something? Square something. Multiply by itself. How many times? Twice. Okay. Yeah. So look what it says here. Hey, if you get something being squared, you don't need to do the box. You could FOIL it out. You could use the box method. That's fine. But this is what we're always going to get. The first term squared plus double each value multiplied plus the last term squared. That's it. Okay? That's it. So remember, if you're going to square everything, this is the product, right? If you take the product and undo it, this is the factors. All right, so just be real about what they're asking you. Remember that. And now let's look at our examples. Do I see one like that? Yes. So right here, A is actually that. A is actually that. So, can you tell me what got, and the reason I know that is because the first and the last terms are squared. So what number is getting squared to start? 4 and x are getting squared. What is the last value to get squared? 5. So watch this. Here's how we know. You take the middle, and it's really 2 times 4 times 5. Does that make 40? If I double 4, I get 8. 8 times 5 is 40. So it's following that. And so what we're going to say is this is 4x plus, what's the last term? 5, and it's being squared. That's it. Quick question. We just said that this is a shortcut for the big X, right? Just to make sure we're not tripping, let's do the big X on this one. Just to refresh your memories of how it works. What's the top have to be? A times C, which is going to be what for us? A times C, you're right. A times C will be what value? 400? 400 has to add up to what? Okay. What numbers will work? What numbers will work? I need two numbers that multiply to 400 and add to 40. 20 and what? 20 and 20? Now, what is your next step? Divide by A. So let's see. What is 20 divided by 16? We can reduce that, right? Remember, every time we get that fraction, what does that reduce down to? No, we want to keep it a fraction, not a decimal. What can you divide 20 and 16 by? Divided by 4. So we divide those by 4, we get 5 over 4. 5 over 4, right? That's as far as I can make it, right? How do you make factors from that? Oh, you guys got to know this. I told you it's critical to what we do. So we say whatever the bottom number is, that goes next to x. Whatever the top number is, that's what adds with it. It's plus because it's positive 5, right? Now, if we have the same if we have the same fraction twice, then don't we have the same factor twice? How do you write the same factor twice? Squared. Think about how long that took us. Was that longer than doing it the other way? If you can memorize that formula, it's going to save you time. Do you have to memorize that formula? No. Will factoring always work? Yes. But why not use a shortcut anytime you can? See what I'm saying? So you've got options. I'm never going to say you can't use your options, but why not use the fastest option? That's what we're trying to get. All right, next, difference of sums. So almost the same, but what sign is in the middle? Subtraction. Now look, this other side, almost the exact same as what we just did, but where's the one change at? This is almost the same as what we just had, but where's the one change? You guys see it? This right here is a minus. So that minus is the only change. Now we're going to use that for this example. I need you guys to do B. X minus 5 squared. You could try it with just the equation. You could try it with a box, whatever you're comfortable with. Can you get it both ways, the same answer? Go. Let's see. Okay, square the first value for me. What's it going to be? X squared, okay. Now, we're going to do minus 2, and then the first value, the last value, and then take the last value, square it. Okay? So that's what the shortcut is. Let's just do that math. X squared. And this will be negative 10x, right? Minus 10x plus what number? Y'all, if we did the box method, would we get that answer? Yes. Do you need to do the box method if you can memorize that formula? No. Some of you guys won't want to memorize it, so you have the box or foiling as an option. But if you can remember, it's going to save you time. It's just pattern recognition. It's up to you. Any questions on that? That's a difference of squares. Do we have any difference of squares on the other page? I don't think so. Okay, last two are the sum of cubes and the difference of cubes. This is when we have something that's being cubed and added. Now, here's what I would start in the formula. It starts out with the same sign. So if it's a cubed plus b cubed, it's going to be a plus b to start. And then here is going to be the opposite sign. So this one's plus, and then right away this one's minus. That's where everybody messes up on the signs. And notice that pattern continues down here for difference of cubes. It's a minus, so the very first sign is going to be minus. Notice that. And then over here again, same kind of character. It's going to change. Right there is going to be the opposite of the minus. It'll be a plus. They're always going to end with pluses. So they end the same way. They're almost the exact same formula, just those sign changes. Okay? Just those sign changes. So it says the numbers that are not or that are being cubed, a plus b, square the first value, multiply the two values together, make them negative, and square the last value. So we'll see that. And we're actually going to see that right here. So we'll do this one together. So first off, is this a difference or a sum if there's a subtraction sign? The difference. Now, how do I know that it's a difference of cube? Well, look, I can see x cubed right there, right? So that's a good indicator. This is going to be a difference of cubes. So what we have to think about is what's the cube root? So I'm going to show you this on the calculator. If you grabbed a calculator, go ahead and get one if you don't have one. But yeah, you might need to know the cube roots. So let me load that up on the calculator real quick. You're going to hit math on the calculator. And do you see cube root anywhere? Which option is cube root when you hit math? As a cube square root. The fourth one? Yeah. So one of the numbers was 27, right? What's the cube root of 27? What number cube makes 27 is 3. And then we got to do a cube root of one more number. What was that other number? 343. So we're going to go to math, hit the fourth option. The cube root of 343 is 7. So we're going to need those numbers. Cube root of 343 is 7. Cube root of 27 is 3. So we're going to need that. We're going to say, you know what? Okay. I need the cube root of the first minus, what's the cube root of 27? 3. Okay. So remember, it is saying that the answer is going to be a minus b. The other factor is going to be a squared minus ab plus b squared. That needs to be a plus. So remember I said the first one's minus, the next one's plus. So we did the first factor. Now we're going to take those values and it's going to help us get the second factors. So take 7x and square it. What are we going to write down? 49 what? X squared, okay. Now it says take the two terms in the first parentheses and just multiply them together. What's 7x times 3? 21x. And then the last answer is square the last number. And it's going to be positive. What's 3 times 3? 9. Done. That's it. That is a difference of cubes. Difference of cubes. You need to know how to take the cube root for that. Did we have to do the big X at all? Nope. You can't do the big X on this one. This one's cubed. Big X only works on trinomial quadratics. So this is a special one you have to memorize. You might star that one, be like, hey, I got to memorize that. Gotta know it, gotta know it, gotta know it. Okay. So here's one. How do I know this is going to be cubed? Because watch. What's x times x squared? Isn't that going to be x cubed, right? So yeah, I can see it. It's going to be a cube. So follow that formula. This is a plus b. This is a squared minus ab plus b squared. So what's that answer going to be? When you multiply that all out, it's going to be a cubed what? Plus what? Plus b cubed. So we have all of that. Now you guys need to tell me what's a cubed plus b cubed and we'll be done. Yeah, what is 2x to the third? Because they're telling you, hey, this beginning part is the a. 8 what? So 8x to the third, okay, plus. And then what's the 5y to the third? 5 times 5 times 5? 125 what? Y to the third, done. Did we have to put that in a box? That would have taken you about 90 seconds to do in a box, right? You would have combined like terms. You would have to do all that. Just like we did on the quiz today. But this is a lot faster if you can recognize what's there and know the formulas. It's going to save you time. It's going to make it easier. If you practice this enough, eventually you'll just recognize it when you see it. I had somebody in 7th hour a couple of days ago, how can you do this so fast? It's because I see these patterns over and over and over again. The more you practice it, the easier it draws itself out. Okay, any questions about those formulas? I'm going to give you all those formulas, but you should start memorizing them. Make flashcards out of them, whatever you got to do, quiz yourself on them. It's not going away. It's going to be on the ACT. They always ask about those. Difference of cubes, sum of cubes. You are going to see it on the ACT. Could you do it with a box? Yes. It's just going to take you a long time. And when you only have an hour to answer so many questions, why wouldn't you want to do anything to save time? It's valuable time. Okay, so we answered all those, right? All right. Let's go to the next page. So, in algebra, where is Pascal's triangle beneficial? And it has to do with this triangle. On the left here, here's a triangle, right? And we were talking about how you get it. This is something you can make from scratch. The first 3 values are all ones, right? Then after that, it always is ones on the outside. How do you get the middle term? You add the previous top spot, right? And that's what we did. We talked about how to get that. This pattern continues forever, right? You can do this forever. It's infinite. It doesn't go away. But now, what we can say is, well, if we take two values and raise it to the 0 power, y'all, what's anything to the 0 power? Try like 5 to the 0 in the calculator. What is that? 5 to the 0? Anything to the 0 is 1. So look, they tell you, hey, if you do anything to the 0 power, it's 1. After that, these numbers in the front are called what? Start with a C. Coefficients, yeah. So the rest of Pascal's triangle tells you the coefficients. So look, 1, 1, 1, 2, 1, 1, 3, 3, 1, and all the way. There's the coefficient, right? Now check this out. This is the other thing that it does. Look at the powers. So what we do is we say, okay, what's the highest power we're doing? What power are we doing? 2. Alphabetically, what letter comes first, X or Y? X comes first. So it starts in descending order. We're going to say squared is the highest, and then 1, and then it doesn't show up, but what X power is there? Now, if it's not there, it's X second, X to the first. Here should be X to the, what, if it's not there? 0. So it's descending. 2, first, 0. Now look what's happening here. Y to the 0, because it's not there. Y to the what? Y to the first, and then?
Second.
The second. So one of them is descending, second, first, 0. The other letter is ascending. It's going up. Y to the 0, Y to the first, Y to the second. Yeah? And it's always going to stop with whatever power is there. So look, we have Q power. Okay, so X to the third. The next one goes down, X to the second. Goes down again, X to the first. This one is X to the 0 because it's not there. Now let's go backwards. This one's Y to the third, Y second, Y first, Y to the 0. Okay? And it's going to do that no matter where you are on the triangle. Okay? So you're going to have a test question like this. On the test, I can say, hey, create the answer for X plus Y to the 9th, to the 7th, to the 6th, whatever. I can ask for any one of them. Do I have to give you this triangle, or is this something you can make? Hopefully something you can make. And then I can say, hey, find X plus Y to the 7th. Yeah? So it's not going away. It's a very useful thing. He's very famous. Hey, look, there's this triangle of the pyramid. It's up there. Yeah, he did a bunch of stuff. He's actually on their money. He's not important in life. Yeah, a lot of French people on there. In Europe, they put mathematicians on their money, not presidents. Isn't that crazy? So that's how that works. Again, notice that for the people watching the video, what we said was, look, X squared, you're going to start with that power here, and it descends on that letter. Second, first. Now it's not there, so really it's X to the 0. We just don't write it. And then the other direction, it goes up. Y to the 0, Y to the first, Y to the second. All those powers need to be there. One of them descends, one of them ascends. It doesn't matter what power you have, it's always going to do that. So we look at X to the third. The X is going to start with that and descend. Third power, second power, first powers, no power. Right? And then the Y does the opposite. Y to the 0, Y to the first, Y to the second, Y to the third. So it's always following that with the letters. So I need you guys to do Y to the 5th. X plus Y to the 5th. We're going to expand that. So they gave us row 0, row 1, row 2, row 3, row 4. We need to do it one more time for row 5, right? So let's do that real quick, and then it's going to be 1, 5, 10, 10, 5, and 1. All right, so use those values and expand x plus y to the fifth. So there's all your numbers that you need. Let's see what this is going to be. The numbers that we just wrote down are your coefficients, right? The numbers that we just wrote down are the coefficients. The power, the row that we're on, tells you how to ascend and descend with your powers. Okay, so we said in the fifth row we get 1, 5, 10, 10, 5, 1. So I wrote those numbers down again. So now those are the coefficients, right? So it's going to be 1, start, and then x is the first letter alphabetically, so that starts with x to the fifth. And then we're going to write it, but we never write this one. It's y to the 0, right? And then is 5 positive or negative? So we're going to say plus 5, x to the what? So it started as fifth power. Now it's going to be fourth, right? And the y is going to go up now to 1. And then the 10 is going to be next. What am I going to write for the letters? X. So x goes down, y goes up. So x to the third, y squared. And then another 10. What about the letters? X squared, y to the third, okay? And then 5x to the first, y to the fourth, and then last one? X to the 0, because it's gone all the way down, and then y to the... Now, do you need to write the x to the 0 or anything to the 0? You can erase it now. You don't need those. So if it helps you to write them in, that's fine. And then just get rid of the anything to the 0. We don't need it. I wanted to erase. So yeah, we don't need those. That's it. Yeah? All right, that concludes our video. If you got any questions, let me know.